Hi folks, this is Nat, and this is going to be your video lesson on naming angles, and we're also going to cover angle relationships, how to recognize them, what they mean, and what we can do with them. So we're going to start off with how it is that we name angles, and there's actually a variety of ways angles get named, and we need to be sort of familiar with all of them. At its most basic, an angle might look like this, for example, and we're not going to go into, the ideas of acute, obtuse, straight, reflex angles, those sorts of things. We're going to assume that you remember those. So I'm looking at this angle, and what I'm primarily interested in today is the ability to name it. And there's a couple ways this might happen. One way, kind of one of the most basics that we see, is you will see an angle with a number written inside of it, like this. And if this is what I see, I can actually call this angle 1, which might be written like this, angle 1. Or you might see it written with the angle symbol, angle 1. And the angle symbol kind of looks like an L that got tipped over a little sideways. Another way I might name an angle or see an angle presented is with just the vertex. And if you remember, the vertex is the point where the angle changes direction, or the kind of origin of both rays of the angle. But I might see the vertex labeled with a point. So let's say that this is point A. I might now name that angle by its point. So I could call it angle 1, or sorry, angle A, because it has a vertex at point A. I could also name it angle A this way. The problem with that method comes in when you see sort of a general shape like this. I've got two lines that are intersecting here, and so I've got a lot of different angles being created. And I could go through and I could actually number them. I could say that this is angle 1, and this is angle 2, and this is angle 3, and this is angle 4. And I'll sometimes see that happen. What I can't do is now call them all angle A, because if I say angle A in this scenario, you don't know which of these angles I'm talking about. So what's going to be more common is actually to add some extra points and name our angles according to those extra points that we add. So here I've added a bunch of extra points, and now I can start talking about particular sections of this angle. And this is actually going to be the best way to do it, because not only will I be able to name all the kind of little angles, but I can name some of the bigger angles that I might not easily be able to either, like the straight angles. Let's say I want to name this angle right here. Much like a plane, an angle can be named with 3 points. This angle would be called angle CAD. You could also name it angle DAC. Those would be the same thing. And what I'm doing when I name my angle this way, and you see again my little angle symbol, by the way, what I'm doing when I name my angle this way is I'm just working around the angle, naming the points. CAD, and that indicates that angle. Same thing with DAC, it's just the same angle but in reverse. One thing that you'll notice is that the vertex will always be named by the center middle letter. So in this case, I can look at either of these angle names and tell that A is the vertex without ever having necessarily seen the angle. Same idea, if I wanted to name the angle going from here to here, or opening this way, I could name that angle CAB, or alternatively I could name it angle BAC. Again, I'm just naming it by the points that make up one for the ray, the vertex, and then the other ray. And that's how you name angles. Pretty easy. Similarly, if I was asked to do something like draw angle XYZ, I could do that pretty easily. All I have to do is make an angle, and I need to label my points on that angle according to this XYZ. X on one ray, Y at the vertex because it's the center letter, and then Z on my other ray, and then I have angle XYZ. That's going to get us into the idea of angle relationships, because once we can talk about angles easily, we can start thinking about, well, what relationships might they have to one another? And the first one we're going to talk about is what are called vertical angles. Vertical angles are what happen at the intersection of two lines. When two lines intersect, no matter kind of what direction they're going in, they create four angles, no matter what. And vertical angles are angles that are opposite each other in the intersection. So for example, these two pink angles that I'm marking here would be vertical angles. Similarly, these two orange angles would also be vertical angles. So they're opposite each other at the intersection of two lines. The reason I care about vertical angles is because they've got the interesting quality of always being equal. So for example, if I know that this one pink angle over here has a measurement of 48 degrees, I know as well that the angle opposite it, its vertical angle, also has a measurement of 48 degrees. Similarly, if I know that this orange angle has a measurement of 132 degrees, I know that the angle opposite also has a measurement of 132 degrees. That's a vertical angle, or those are vertical angles. And what we would say is that vertical angles are always congruent, which brings us to another important vocabulary word. In geometry, whenever you hear the word congruent, we're basically talking about things that are the same in terms of measurements. So if two angles are congruent, they have the same measurements. If two triangles are congruent, they have the same length of sides and measurements of angles. If two line segments are congruent, they have the same length. So the congruent in geometry always means the same, and it's going to be a word that you hear a lot and you're going to need to get used to. That gets us to supplementary angles. When we say two angles are supplementary, what it means is that their angle measurements add up to 180 degrees. So if I look at these two angles and I tell you these two angles are supplementary, what it means is that, again, the sum of their angle measurements is 180. So if I know that my first angle here is 120 degrees, I will also know that this other angle has a measurement of 60 degrees, because that's what it would take so that they'd add up to 180 together. Now, while supplementary angles don't have to be attached to one another, we can really frequently recognize them when they are. This, for example, is a super common shape in geometry. What I've got here is a straight line, which I might also refer to as a straight angle, with a single ray coming off of it. And whenever I see a straight line is a straight angle, and a straight angle has a measurement of 180 degrees. So what I know from that is that the two angles that are attached to it must be supplementary. They add up to 180 degrees. So if I see this shape, and I know that this angle over here is 40 degrees, I also know the obtuse angle as well. It's going to have to be 140 degrees. Because again, they'll be supplementary, and that's what it'll take to add up to 180. The same thing applies to line intersections. If you see where these two lines have crossed one another, each line is its own straight angle. It has a measurement of 180 degrees. So any way that I split it in half also must make 180 degrees total. So when these two lines cross, not only do they make two sets of vertical angles like we talked about a minute ago, but they also make sets of supplementary angles. So if I know, for example, that this angle is 150 degrees, I know that the two angles that are next to it along either of those straight lines must be 30 degrees, because again, that would add up to 180. I also know the angle across from it, by the way, is 150 for one of two reasons. One, because they're vertical from one another, and also because it's got its own supplements on the other side. So it's next to those two 30s, again adding up to 150 or 180. Complementary angles are the same, except with a different measurement. Complementary angles add up to 90 degrees. So again, as an example, if I tell you that these two angles are complementary angles, and I know that one of them is 30 degrees, I know that the other then must be 60, because that's what would add up to 90. A lot like supplementary angles, there's an easier way we see these frequently. I'll frequently recognize complementary angles because I'll see a 90-degree angle that has been split into two pieces. And if I know that they sum to 90, same logic as before. If I know one, I should know the other. So if this is a 70-degree angle right here, that means its partner, its complement over here, must be 20 degrees. So beginning to recognize those sort of shapes that we frequently see, both with complementary and supplementary angles, is going to be super important. Finally, it's going to be worth knowing what an adjacent angle is. Adjacent angles are angles that share a ray. For example, in this top drawing here, the two small angles that we see are adjacent to one another because they share this ray. That makes them adjacent. On the bottom one, we've got a bunch of adjacent angles. I could say that this angle is adjacent to this angle because it shares this ray. I could say that that angle is adjacent to this one because it shares this ray. There are also some angles that aren't adjacent. For example, the small angle there is not adjacent with this one because they share no ray. They touch at the vertex, but that does not make them adjacent. They have to share a ray to be adjacent. So the last thing we're going to do is take a second to put all this information together. Just because it's a lot and it's easy to kind of miss some of these things that we were talking about. So let's say that for some reason I needed to fill in all the different measurements that I've been missing, or that are missing from this diagram. Well, we can start by using some of the relationships we talked about. And the first one I'm thinking about is a vertical relationship, vertical angles. I see that I have two lines crossing each other. And I know that when the two lines cross, opposite angles are vertical. For a second, I'm imagining that this line doesn't exist, and it's just two crossing lines. And what I can learn from that is that this line, or this angle, angle DCE, is vertical with ACB. It's across those intersecting lines, which means that it must be the same. So this angle has to be a 40-degree angle. Again, because it is vertical with the one across from it, the 40-degree angle across from it, ACB. And I know that vertical angles are always congruent. The next thing I can do is use a little bit of my supplementary relationship. I notice that this is a straight line, a straight angle. And so when it is split by this ray into two pieces, here and here, angle ACB and BCD, those two pieces must be supplementary. So again, I can quickly then calculate the missing angle. I know that this one must be 180. You might notice as well that it is it's not 180, 140. You're going to notice as well that it's, hopefully at least, that it's supplementary with this one over here. Here, because it's in a 90-degree angle that's split in two, I can say that this missing angle must be complementary with the 40-degree angle I've already put in. The complementary angle to 40 is going to be 50, so that'll add up to 90. And then a full circle, just so we kind of talk about this, is 360. So whatever's missing, this last little chunk, has to be 360. But I also might recognize that it is actually supplementary with this 90-degree angle here. So this missing angle, this last angle, is going to be 90 degrees. And here are your practice problems. Use the diagram to answer all three questions. Good luck.